Hi, this is Matt at LSAT Lab. Today's lesson is on standard ordering games in the logic game section. Today we want to discuss first how to spot one, then the process that you want to take for approaching them, and then look at a couple of the different features that are common to standard ordering games: subgroups, non-one-to-one, and frames. So inside of the world of logic games, 50% of all logic games ask you to order a set of elements. So 28% are standard ordering games. So the biggest game type out there, and it also has a wide variety of things that can happen. And so let's get started. The way you spot a standard ordering game is that the scenario is telling you that it's an ordering game. They're telling you to put players into order, or that they're going to be arranged consecutively, or some of them are before or later or earlier, or however they want to say it, but that there's going to be a sequence of elements here. And so you can write out your cast of characters, set up an order line. It's important, though, that it's not the kind of game where all the rules coalesce to build a tree. That's a tree ordering game, which is a special version of ordering. And it's not the kind where you're going to need to track multiple character sets so that you need multiple rows to do so. So it's not a stacked ordering game. This is kind of like the vanilla of logic games. So the rules that you're looking out for are, first, position exclusions, where they rule out a particular player from a particular position. Relative relationships, where they tell you that one player is in front of or earlier than another player, or later than. You're also looking out for fixed relationships. So these are blocks or anti-blocks, or blocks where you have like positions in between the elements. And then conditional relationships, where they give you like an if-then rule. Maybe if K is third, then L is fourth. And so these are the rules you need to be ready to handle when you're working on a standard ordering game. The first step in the process is to build a game board. So let's take a look at a game here. In this game, they tell us that there are 6 saxophonists: F, G, H, J, K, and L. So we have 6 elements. And then they tell us that each audition will begin on the hour, with the first beginning at 1 p.m., and the last beginning at 6 p.m. So we're supposed to take these 6 saxophonists and order them 1 through 6. Then after we have a game board set up, we want to notate the rules. And so in a game like this, we take that first rule: Jackson auditions earlier than Herman does. So J is earlier than H. We can use a relative relationship to set up that rule. And then we have another relative relationship. Gabriele auditions earlier than King does. So we have another one. And then we get to another rule that says Gabriele auditions either immediately before or immediately after Louder does. Now, they're not telling us whether G is earlier than L or L is earlier than G, but we know that they're consecutive. So we can put them in a block and then put this little arrow across the top that allows us to flip that block so that we know that this block is reversible. And then finally, we get a rule that says exactly one audition separates the auditions of Jackson and Louder. So we have another block here, but this one has an element between the J and the L. So we're going to create that block with one space between the J and the L, and again, the arrow across the top that allows us to flip that block backwards and forwards. So we know that the order of J and L is undetermined. Then after we notate the rules, we want to take a second and see if we can find any inferences for this game. So one of the more important and early inferences that you might make is whether or not all of the elements are involved in the rules. So if we look at the elements F, G, H, J, K, and L, we notice that F is not involved in any of the rules. Maybe we want to underline it or circle it, somehow draw our attention to it, so that as we're placing elements into the order line, as we're completing a hypothetical, if it's ever the case that we're not sure who's left, who do we need to place, typically those floaters are the characters that might come under the game board last, and we might have used the rules to fill in some of the positions, but if we're trying to figure out who's left and we want to remember it really quickly, by underlining it or circling the floater, it helps draw our attention to that character as we come back and look at the roster of elements. Otherwise, there's not a lot to be done here in terms of setup. There isn't any block that can be limited to a couple of different places. There aren't any elements that we can place under the order line at the outset. So this game has very few inferences. And then once we're done looking at those inferences, we want to move on to the questions. So here's the first question in this game. Go ahead and pause the lesson. Try this question on your own, and when you think you have an answer you like, come back and we'll work through it together. All right, so this is called a rules question. And a rules question is typically the first question in the set, and it's testing your ability to understand how the rules play out. It's actually a fairly straightforward question. You can apply the rules one at a time, knock out the wrong answer choices, and the answer remains as correct. So if we look at that first rule, J is earlier than H, we see that answer choice D breaks that rule. And so we can eliminate and move on to the next rule. G is earlier than K. Well, answer choice B breaks that rule, so we can eliminate that one. Then we look at the rule about G and L being consecutive. We see that answer choice A breaks that rule. And then we know that J and L are separated by 1, but answer choice C has them separated by 2, so we can eliminate answer choice C. And through deduction, we can get to answer choice E as the right answer. And that's the process you want to take when you're working on a rules question, pretty much regardless of the game type. Except for tree ordering games, there's a slight variation that you want to take for that one. But otherwise, simply just take the rules, knock out the wrong answer choices, and what you're left with is the right answer. Now, another kind of question is called a local question. And a local question essentially gives you a new piece of information within the question stem on which you're supposed to answer this particular question. Now, that new information disappears when you move on to the next question. So it's only applicable for this particular question. The process that you want to take is you want to plug that piece of information in, see what follows from it, and then use that in order to answer any of the questions or to work through each of the answer choices. Try this question on your own. When you think you've got an answer, hit play again and come back and we'll do it together. Great, so welcome back. Now, they're telling us that F is not first, so we can plug that into the order line, to the game board here. But that doesn't really give us a whole lot to work with. So in this case, what we're probably going to need to do is kind of work through each of the choices one at a time to figure out which one of these could be true. We'll just go to A, and if it works out, great, we'll pick it. If it doesn't work out, we'll go on to the next one. And eventually we'll get to an answer choice that could be true. We'll pick it and move on to the next question. So answer choice A says that H's audition is scheduled to begin at 6. If we plug in H at the 6th position, what does that tell us? Well, we're just trying to make a scenario that works. Since H doesn't really tell us anything, we know that J is earlier than H. We could plug in J anywhere. So long as we can come up with a hypothetical that works, we can pick this answer choice. So if we put J into the first position, that gives us lots of room so that if we want to put, if we put J into the first position, L is going to have to go into the third position. And now we have to deal with the fact that G and L are consecutive, as well as keeping in mind that G is going to be earlier than K. So if we put G second in order to give it more room to be earlier than K, that leaves K and F left over. We could just drop them into the 4th and 5th positions and see if this hypothetical satisfies all the rules. In this case, J is earlier than H, G is earlier than K, G and L are consecutive, and J and L are separated by 1. So, and we also satisfy the new piece of information from the question stem that F isn't first. This works. So on test day, we could just simply pick answer choice A, mark it, move on to the next question. If we wanted to think about how would we test wrong answers, let's just take a look at answer choice B. If we put G into the 5th position, what does that tell us? Well, we know that G needs to be earlier than K, so that would force us to put K into the 6th position. And we also know that G and L need to be consecutive, so that would force L into the 4th position. And since J and L are separated by 1, that's going to force J into the 2nd position. Now we know that J needs to precede H, so that's going to force H into the 3rd position. And look who's left, F. And it's stuck going into the 1st position. So by putting G into the 5th position, that forced a series of events that put F back into the 1st position, which is what this question prohibited. So that doesn't work, and we could eliminate it and move on to the next answer choice. And I'm not going to do it here, but each of the other answer choices breaks the rules in a similar way. So now here's another question type. It's called a global question. It doesn't give you any new piece of information, and it's not a rules question. It's just asking, what do you know based off of the original set of rules? Now, one thing you could do is you could use your previous work in order to help maybe figure out what has to be true. And rather than looking for things that are true in your other scenarios, because they could be true, but they don't necessarily have to be true, you might use your other hypotheticals to make eliminations. So rather than showing what is the case in a hypothetical, if you can find a hypothetical that you've previously done that contradicts one of these choices, you can make the elimination. So if we look at our work from the last question, the right answer, we put J in first, G in second, L in third, F, then K, then H. We know this is a hypothetical that works. So any answer choice where it doesn't conform to this doesn't have to be true. So, for example, does G have to be scheduled to begin before 5 p.m.? Well, we have G before 5 in answer choice A. So we can't eliminate A because that, as far as we know, that might still need to be true. If we look at answer choice B, H is scheduled to begin after 2. Well, we have H at 6, so that's still something that may need to be true. H is scheduled to begin before 6, according to answer choice C. Well, no, H doesn't need to go before 6. This hypothetical shows that H could begin at 6. So using our work from the last question, we could eliminate answer choice C. Answer choice D, K's audition is scheduled to begin before 6. Well, we have that, so we can't eliminate it. L's audition is scheduled to begin before 5. We have that, can't eliminate it. We might also look at the first question that we looked at. In that case, it went J, G, L, H, K, F, 1 through 6, and we might be able to use that to make further eliminations. Now, the test writer is pretty good at using or avoiding your ability to use that first question, the rules question, which is a valid hypothetical, to get rid of or answer questions. But let's just take a look and see what happens. G is scheduled to begin before 5. We have that, so can't get rid of A. H is scheduled to begin after 2. We have that, so can't get rid of B. D says K is scheduled to begin before 6. Have that, can't get rid of D. L's audition is scheduled to begin before 5. Have that again. So that the answer to the rules question wasn't very helpful in terms of eliminating any answer choices, but the answer from question 5 was able to. So now, if you're in a position where you can't use your previous work to make eliminations, you're going to have to work through them each one at a time. Rather than plugging in each choice as is, all you'd be testing if you did that would be that it could be the case. What you need to do is show that it must be the case, and the best way to do that is to test cases. So you want to create counterexamples to see if it's possible that G could begin after 5 or at 5. Now, we know that G really is not, it's going to be tough to get G after 5. If we put G in the 6th position, remember, G needs to precede K. So there's no room here to have K follow the G. But what we might try doing is putting G at the 5th position. If this works, then we could eliminate A. If it doesn't work, then we know that G's addition needs to begin before 5, and we could pick it as the right answer. So if we put G 5, then we put K 6, and we know that G and L need to be consecutive, so L would go 4, and that J and L need to be separated by 1, so that's going to force J 2. We know that J needs to precede H, so that's going to force H 3, and that leaves F to go in position 1. And remember, in this question, it wasn't the case that F was precluded from position 1. So this actually works. So does G need to begin before 5? No. G could begin at 5. And so we can eliminate answer choice A and then go check answer choice B. So we're just trying to test the opposite of what the answer choice is saying to figure out whether it had to be true or whether we can get rid of it. So if we look at answer choice B, H's audition is scheduled to begin after 2. Oh, before we do that, we should use our current situation to see if we can make any further eliminations, right? So we have a valid hypothetical. We've already built it. Why not take the time to use it to see if it can get rid of any other answer choices other than A? So for example, in D, K's audition is scheduled to begin before 6. Our hypothetical shows that K doesn't need to begin before 6. K could begin at 6. Let's just check E while we're at it. L's audition is scheduled to begin before 5. Okay, so that is true here. Can't eliminate it, so we can go on to create a new hypothetical to test answer choice B. So if we put H into the first position, we know that we're trying to test whether it must be true that H is scheduled to begin after 2. So if we could make H work in either the first position or the second position, then we could eliminate answer choice B. If you put H first, this is going to make it very difficult for J to precede H according to the first rule. So let's try putting H second. If we put H second, then the J has to go in front of it, so J will go first. And J and L are going to be separated by 2, so L will go third. And then G and L need to be consecutive, so G would go fourth. And then G needs to precede K, and F needs to go in there somewhere. So K and F can basically just fold into 5 and 6. Let's just test this hypothetical against the rules. J is before H, that's true. G is before K, that's true. G and L are consecutive. J and L are separated by 1. So this hypothetical works. Does H need to begin after 2? No, we just showed that it could begin at 2. So let's take a look at answer choice E. L is scheduled to begin before 5. Well, that's still true in the hypothetical we created for answer choice B, but let's see whether or not we can get L to begin at or later than 5. If we put L at the 5th position, we might decide to put J in the 3rd position. In fact, we have to put J in the 3rd position because J and L need to be separated by 1. And now we know that J needs to precede H, and G and L need to be consecutive. So how we decide to put G and H into 4 and 6, I think they can flip-flop back and forth between the 2 positions. So we can just use a split option to notate the idea that H and G can go into 4 and 6. We also know that, looking at the rules here, G is before K. Uh-oh. G needs to be before K, but regardless of whether we put G4 or G6, there's no room for K to follow it. So yeah, if we try to put L into the 5th position, it's simply not going to work. If we try to put L into the 6th position, we could try this as well. L goes 6th, then J is going to go 4. If J goes 4, since J is before H, H would go 5. But wait a minute, G is supposed to go next to L. So we're running into a problem where G is supposed to precede H and G and L are supposed to be consecutive. That 5th position is going to be contentiously fought between G and H. It doesn't work. And so that's why L does need to begin before 5. We tried putting it at 5, it didn't work. We tried putting it at 6, it didn't work. And so we can prove that answer choice E must be true. So let's look at some of the features that are common to standard ordering games. Now, subgroups isn't terribly common. 7% of standard ordering games involve subgroups. And remember, subgroups are when you have different kinds of players. So maybe in the scenario you're being asked to order, let's say 6 people, 3 of which are volunteers and 3 of which are employees. What that's going to do is it's going to change your roster so that you're going to have 2 categories of players, one set of volunteers and one set of employees. Now, some people, they want to create more of a distinction between the characters so that when they're placing them under the number line, that they can remember who is who. So one way you can do that is you can create uppercase and lowercase characters. Now, this works when you have 2 different kinds of players, but it doesn't really work when you have 3 or more kinds of players. And so in that case, you're probably going to need to maybe either use subscripts, which you could do as well. But generally speaking, I find that it's not too hard to just simply write out the players. They usually keep them in far enough distances within the alphabet that you're able to keep track of who's who just by kind of looking at the letters and knowing roughly where in the alphabet they are. Another common feature is non-one-to-one games, games where you have an uneven number of players to position. 25% of standard ordering games involve this particular feature, so it's an important one to master. And there's a few ways in which it can play out in a standard ordering game. So one way is where you have more elements than positions. So each element is assigned to exactly one position, and each position is assigned to at least one element. So if you have more elements than positions, and each element is assigned to exactly one, and each position is assigned at least one element, that means that some of those positions are going to need to have more than one element. And so what you might find is that you're going to need to be flexible, that it's not going to be exactly one element, one slot. Some of the slots are going to need to house more than one element. If you have more elements than positions, and each position is assigned exactly one element, and you have, say, 7 players but 5 spots, then some of those players aren't going to go. Some of those players are going to be left out of the order line. So some of those players, what you probably want to do is create an out group. Those, if you're going to order 5 of 7, then create 2 extra slots and call them out. That way you can track everybody as you're creating your hypothetical. Where you can get into trouble is where you're placing some of the players onto the order line, and by not keeping track of who's out, you can sometimes forget. And also, if you can fill out those who are in the out area. So for example, if you could determine that G and J were not going to be ordered in this particular hypothetical, well, that would allow you to figure out that F and H and K and L and M all have to be ordered. So sometimes by keeping track of the ones who are out, it allows you to make inferences about those who are in. A different version would be where you have fewer elements than positions. So if you have 4 elements and 5 positions, and each element is assigned to exactly 1 position, well, then some of those positions are simply going to be left out. They're going to be left open. And so you might need to start creating some slashes on those positions where nobody's going to go. And another variation would be where you have fewer elements than positions, but each position is assigned exactly 1 element. So in this case, there's not going to be any open spaces left over. But in order to make that happen, some of the players are going to have to go more than once. So keep in mind, when you have more players than positions, it's possible that either some of them are going to be left out, or that some of those positions are going to have more than 1 player assigned. If you have fewer players than positions, either some of the positions are going to be left out, or some of the players are going to have to go more than once. Next, frames. Frames is an approach for logic games where you're able to create a master set of solutions before you even look at the questions. And this is the tactic that can really make you move fast. This is the tactic that enabled me to complete games in 35 minutes, or take the time that it takes me to complete a set of games from 35 minutes down to sometimes like 20 or 22. This is like a monumental shift in terms of how fast you can move if you can good at recognizing when frames are available and making inferences within those frames so that you can approach the questions quickly. The way in which you create frames in standard ordering games is with blocks. So what you're really looking for is a block that's limited to 2 or 3 places on the game board. If you have a block that creates like H space K and a number line that goes 1 through 5, well, that block can either only go in 1 through 4 or 2 through 6. And so you can create 2 rows, 1 for in each case, and then use the rest of the rules to see if you can make any further inferences before you look at the questions. So the process for logic games in general, remember, is first you create the game board, then you notate the rules, then you make any inferences that are available, and then you look at the questions. You spot a standard ordering game by recognizing that it's an ordering game, and you also see that it's not a tree ordering game and not a stacked ordering game. And then finally, you want to use an order line as the game board for this particular game type. The rules, you want to be looking out for position exclusions, relative relationships, fixed relationships, and conditional relationships. And for frames, you want to be looking out for blocks that can be limited to 2 or 3 places on the game board. So that's it for standard ordering games. I invite you to check out some of these other videos or visit us at lsatlab.com today.